Okay, this time we're going to discuss normal distribution curve as a probability distribution curve. We're going to solve the following problems. Find the probability that the value of z is between 0 and 2.52. Now, probability actually is just the same as the area under the normal curve. They are related in a sense that the total probability is 1 or 100%, and the total area under the normal curve is also equal to 1 or 100%. So we can represent the area under the normal curve in terms of probability. That means that if you have the normal curve, the total area is under that curve is 100% or 1, or the probability that the value of your z is between negative infinity, positive infinity to negative infinity now is also equal to 1. Okay, so how do you find the probability that z is between 0 and 2.52? Again, we use the diagram, draw a normal curve, then look for the point where 0 and 2.52 are located. So when you say probability that your z is between 0 and 2.52 is just the same as finding the area under the normal curve between 0 and 2.52. And how do you find that? Based on our discussion last time, we used the table for standard normal curve. Okay, so we refer to this one. What we do again is to look for 2.5 in the rows of the table. So 2.5 is here. Okay, and look for 0.02 in the column. 0.02 is here. Okay, so 2.5, 0.02, the area is 0.4941. That's the area between 0 and 2.52, which is also the probability that the value of your z is between 0 and 2.52, which is 0.4941. 4941. You can also choose to write this as a percentage. So you can write this as the probability that the value of your z is between 0 and 2.52 is 49.41%. Okay. Let's move to letter B for our second example. What is the probability that the value of your z is less than 2.01? Always we use the diagram because the diagram serves as our guide to find for the area or the probability. Where do you find 2.01? You find it to the right of 0. Find it here. 2.01. And we say z is less than 2.01. That's the same as finding the area to the left of 2.01, right? Okay. Which means that the area to the left of 2.01, or the probability that your z is less than 2.01, is equal to the area of half of the normal curve, which is 0.5, plus the area between 0 and 2.01. which we can find in the table. So again, we look for 2.0, okay, here, and under column 0.01, which is here, okay, 2.0, under column 0.01, we have 0.4778. So add it here, 0.4778. Then adding them, we have 0.9778, which is the probability that the value of your Z is less than 2.01. And last example, what is the probability that the value of your Z is greater than 1.98? We again draw the table. Look for 1.98. 1.98 is here to the right of 0. 1.98. So when you say probability that your Z is greater than 1.98, it's the same as the area under the normal curve to the right of 1.98. So how do you find that? Since it starts from 1.98, we cannot directly use the table. So what we do is, again, find the area to the right of 1.98 by subtracting the area of half of the normal curve, which is 0.5. Okay. Then subtract from that 0.5 the area between 0 and 1.98. So what is that? Look for 1.9 again under column 0.0, column 1.9 under column 0.08. Okay, this one here, which is 0.4761, right? 0.4761. 0.4761. Okay, that's the area between 0 and 1.98. So we subtract it from 0.5. And we are left with the area to the right of 1.98, which is also called as the probability to the right that your Z is greater than 1.98. So subtracting this, we have 9. We have 3. Okay. We have 2. And then 0. Okay. So you have 0.0239. Okay. For the so the probability that the value of your say is greater than 1.98 is 2.39%. So you can write that also as 2.39%. Okay. Okay, so that's it. For our next video, we will discuss examples where we find the value of Z when the area is given.